All right, welcome back, guys. Let's talk some more about static electricity. All right, so what causes static electricity? Most static electricity is, I think about it like the electrons have been taken off one object and placed on another object. Now, that other object has an excess of electrons. It has more electrons than it does protons. Each electron starts to add a little bit of a charge, okay? So now we have this difference in charge. Now, how do you get one electron to another object? Well, usually it has to be rubbed off somehow, and in most cases it's through friction, right? So friction causes what calls charge separation. Now we have more electrons over here than we have on this other side. Electrons are stripped from one material and added to another. All right, so now we have what's called static electricity. Static just means stationary. It doesn't move, so it's not moving electricity. It's electricity that's confined to an object at rest, or confined to an object, and we say that the electricity is at rest. Okay, so let's move on to the next board. Okay, so we can broadly define these objects in terms of what they do with this static electricity. We can divide objects into whether they are conductors or insulators. A conductor is some material where electrons flow freely. Think of like metal wire, copper wire, that type of thing. An insulator is the opposite. It's where the electrons do not flow freely. Think the rubber on the outside of a wire. That's why it's there, so it doesn't shock you. Wood doesn't flow very easily. So these electrons in metals or any conductors, they get passed around very, very easily. They're not attached to any one atom. In insulators, the atoms are a little more selfish about them. They like to hold their electrons close to them. They're tighter, so they don't let them flow around to their neighbors. Now, if you've ever been shocked in your life, you have probably heard of the next word here. We're talking about grounding. What is grounding? So if I have an excess of a charge built up on something, those electrons don't like being next to each other. They want to get away from each other. They're trying to go to the positive charges. So what is the biggest positive charge of them all? It's the Earth. So all excess charges try to go to a positive charge, and if they have any, the biggest positive charge of them all, biggest container of positive charges is the Earth itself. So if you can attach through a wire a device that is grounded, so to speak, it touches the ground, you give those excess electrons a way to go out, and that's why we have grounding plugs on all of your electronics. So if there is some electrical short or some problem in your wiring, that buildup of excess electrons has a way to go safely to the ground and not through you to the ground. It's a definite safety device. All right. So when you watch the video, there's a little device they call an electroscope, and this is some of your problems may have these symbols drawn up, so we might as well talk about them. They look like little stick men. An electroscope, if you watch the video, is simply a little metal ball, and it's attached to a little metal rod, and on the ends of these are little, think tinfoil. There's tinfoil leaves that are kind of just resting here. And if we can use these to show a transfer of electric charge, and I'm going to show you kind of some examples of what's going on. So the one on the left here we have is what we call a neutral. And we can think about what it looks like to be neutral. A neutral just means you have an equal number of charges. And the charges are equally spaced out. Positives and negatives over here, and positives and negatives down the line. You know, everything's spaced out, everything's equal, nothing's going on. If I had an example of a charge, so what if I added some electrons onto here? Or what if I brought a negatively charged rod close to this? Well, then I'm going to end up charging the system. The negative electrons, they don't like being next to this extra negative rod over here. So the electrons are the ones that can move, so they migrate down into the leaves and they start to separate. They get away from each other. And what is left behind up here is the positive charges. Now the positive charges are not actually moving. Remember, they're just the protons. They just get left behind as the electrons move around. Now what would happen if I removed this? Well, if I remove the charge, then slowly these electrons will start to migrate back up and it would turn into this. It would go back to a neutral state. The electrons don't like being next to each other here any more than they like being next to that really big negative charge over there. So they would start to migrate back. This is called induction. Induction is charging an object without touching. If you've ever been near an electrical source and you feel the hairs of yourself stand up on end, that you're being induced with electricity. There's a large charged object and it's pulling your hairs or whatever you can feel at a distance. You can actually feel it being induction. Now, what if I touch the rod to the stick? Now these electrons can pass into the rod directly. This is like connecting the wire, right? We call this conduction. And it's called charging by touching. It's probably the simplest way of phrasing that definition. And it is charging this object by touching it. And these electrons would jump into this electroscope and they would run down the leaves and they would also do the same effect. It would charge it and the leaves would separate. And you can see that there's a charge there. Induction is temporary. Conduction, if you remove the rod, is permanent. Because if I remove this rod now, after I touched it, once I leave it, I have these excess electrons stuck on here. So the electrons would actually stay on here and they would stay charged, keeping the system open. So I'm going to leave it off that today. I want you to have a good weekend. And if you haven't finished your test yet, good luck on that. Make sure you get everything turned in on Friday.